All right, in this screencast, I'm going to talk about sample spaces and events, two concepts that are really important for understanding probability. So first, let's talk about the sample space. The sample space is the set of all outcomes, for example, of an experiment. When we're talking about scientific experiments, so this would be all of the possible outcomes of a particular experiment. We can have a discrete sample space or a continuous sample space. For when we're looking at coin flipping experiments, for example, taking 10 coins and throwing them down in one single toss and looking at the number of heads out of those 10, we could have 0 heads, 1 head, 2 heads, 3 heads, all the way up to 10 heads. That represents a discrete sample space because it represents a finite set of possible outcomes. However, when we're looking at something else that can take on a continuous interval, we refer to this as a continuous sample space, so an interval of real numbers as possible outcomes. This interval can be constrained. For example, if you're looking at the weight of a granola bar that's produced by a certain company, then you would have some sort of interval. An event is a subset of the sample space. Graphically, if we have our sample space as this bigger area, the event would represent this area here that I'm shading in red. So that would represent an event. So that'd be a subset of the sample space. That might be getting 6 heads in 10 coins. So now we're going to talk about a couple of basics of these subsets known as union, intersection, and complement. By the way, sometimes we just refer to these events as circles. So that's the notation I'm going to follow in the rest of this screencast. So let me talk about union, intersection, and complement. If we have two events here, we have event 1 on the left and event 2 on the right. The union of these two events, oftentimes denoted with this big U, that represents a union between events 1 and 2. And this includes the sum of all of those items in events 1 and 2. So we would shade then this entire region that contains both of event 1 and event 2. And oftentimes you can kind of think of this as an OR. So that represents event 1 or event 2. So if events 1 and 2 were two events that were not mutually exclusive, I'll talk about mutual exclusivity here in a few minutes, then you can have an intersection. Speaking of intersection, the intersection is denoted by this upside down U, and you can think of that as an AND. This would be event 1 and event 2 happening. And that would be represented graphically by this shaded region. So that's the intersection. So the intersection is when both events happen. The complement of an event, also denoted by this apostrophe, essentially you can think of as not. So it's not event 1. And graphically here you might think, well, it's not in this circle on the left, so that means it has to be everything to the right. That's somewhat true, but remember, these events are subsets of a sample space. And so really, if this is event 1 and this is event 2, as we had in the previous slide, the complement of 1, or not event 1, would really represent everything in the sample space outside of E1. It's not just the area in event 2 that's not in the intersection, but it also includes everything else in the sample space. So you got to kind of keep that in mind. Mutually exclusive. Two events are mutually exclusive if their intersection is the null set. You kind of think of the null set as 0. There's no intersection. For example, if event 1 was a particular person was born in Colorado, event 2, a particular person was born in Kansas, there's obviously no intersection because you can't be born in Colorado and be born in Kansas. I guess if you're right on the border, you could, but for all intents and purposes, that intersection is 0. You can't simultaneously satisfy both of those events. Something that would not be mutually exclusive would be if event 1 lives in Colorado, event 2 is born in Kansas. You certainly can be born in Kansas but live in Colorado. And in this case, the intersection is not the null set or not 0. It actually has the potential to contain actual items. Sometimes we represent mutually exclusive events as just circles that are non-intersecting. So you see they're not overlapping, which means that the intersection is the null set or 0. So hopefully you learned a little bit more about events, sample spaces, unions, intersections, and mutual exclusivity in this screencast. Thanks for watching.